Hello, hope this thing's recording. The directions on this one say to factor completely, and when you try to factor a trinomial, or when you try to factor anything for that matter, always look for a common factor first. We see that there's a t in all three of these terms, so we can factor out some power of t. Looks like t to the fourth lives in all three terms. We can factor out a t to the fourth. And now look at the coefficients. 3 goes into 6, and I would suspect that 3 might go into 45. You know, there's a rule of divisibility for 3. If you add the digits of a number and 3 goes into the sum, then 3 will go into the number. So look at 45. 4 plus 5 is 9. 3 goes into 9, so I know 3 will go into 45. I may not know how many times it goes, but I know it'll go. So we could factor out a common factor of 3t to the fourth in this one. And as a matter of fact, you can see that was factored out. Let's do a similar exercise so that I can show you from the start. So I'll click similar exercise. Here's a new one. There's a z in all three terms. I think we can factor out a z to the sixth. 4 goes into 4, 4 goes into 4, and 4 goes into 24. So we can factor out a 4, z to the sixth. We'll start with that. Let me write the problem down first. Pause this for a moment. Did I pause it? Did I pause it? No, I didn't pause it. Okay, I think it's recording again. Yes, good. I wrote down the problem. 4z to the 8th minus 4z to the 7th minus 24z to the 6th. I see that there's a common factor of z to the 6th in all three terms. And there's also a 4 that lives in all three terms. We can factor out a common factor here, a 4z to the 6th. So let's do that. We'll write down 4z to the 6th. And then we'll open up a big parentheses, big enough to hold what was already there. And we'll pretend we're distributing that 4z to the 6th. 4z to the 6th times what would go here to give us a 4z to the 8th? Well, we've already got the 4 that we need on the outside. We need to come up with a z to the 8th, and we've got a z to the 6th on the outside. That means that z to the second power, z squared, should go here. Let's check that real quick. Is it the case that 4z to the 6th times z squared is 4z to the 8th? Why, yes it is. Now a positive times a negative is a negative. So 4z to the 6th times what would give us 4z to the 7th? Well, a z to the 1st, or a z. Finally, a positive times a negative is a negative. 4 times 6 is 24, and the z to the 6th that we need we already have on the outside. So now we've factored out the common factor. Next thing is look at what's left inside the parentheses. That's a quadratic trinomial that can be factored using the trial and error method. So we bring down the 4z to the 6th that we already factored out. Bring down the 4z to the 6th. And put up two sets of parentheses. Parentheses times parentheses. Each one big enough to hold a binomial. Now the only way to get that z squared that's at the beginning would be to have a z times a z in the first spot of each of those two binomials. So the only way to get a z squared is to have a z times a z in the first spot of each. And now we're looking for factors of the constant term that would combine to give the middle coefficient, which you don't see, so you know what it is. It's a 1. That's a 1z right there. So we're looking for factors of 6 that would combine to give a 1. Well, the factors of 6 are 1 times 6 and 2 times 3. And the factors of 6 then that would give us a 1 would be a 2 and a 3. Now what kind of a 1 is that 1? Well, it's a negative 1. Using a 2 and a 3 to come up with a negative 1, what would the signs have to be on that 2 and the 3? And remember, you always keep the sign of the larger, right? So the 2 has to be positive and the 3 has to be negative. Positive 2 and a negative 3 would combine to give the negative 1. So in the parentheses here we have a z plus 2 and a z minus 3. And that should be our answer. Let's check that and see if it is. Let's go back and try that. 4z to the 6th. And then we have in a parentheses z plus 2 times in another parentheses z minus 3. Let's check that. Ooh, we got it right. You should watch the videos that I've made in MediaSite. Remember, you can access that from my courses. Hope that helped. Bye-bye.